Good morning all of you. Now we are going to start a new branch of mathematics, that is trigonometry. Trigonometry is a branch of mathematics which deals with the measurement of sides and angles of a triangle. Okay, so in this we will learn how to measure the sides and angles of a triangle. So here in this we will take a right angled triangle. Right angled triangle. You all are aware of this right angled triangle. Okay, so which topic we are going to learn about? Trigonometrical ratios. So in trigonometry, about trigonometrical ratios we will learn here. Trigonometrical ratios. So trigonometry means what? It is a branch of mathematics which deals with the measurements of sides and angles of a triangle. So here in this we will take a right angled triangle, and in that we will learn how to measure the sides and angles of that particular given triangle. Okay, so here we all know about this right angle. Now this is one right angle A, B, C. So here it is a 90 degrees. The side opposite to this right angle we call it as a hypotenuse. Okay, this is common for all the right angled triangles. Means the side which is opposite to the right angle we call it as a hypotenuse. Now suppose if we take the angle here, then the side opposite to this angle we call it as a perpendicular. Perpendicular. Perpendicular means the side opposite to the required angle. See, for this right angle, the side opposite to this right angle will be common for all the right angle triangles, that is hypotenuse. But the side opposite to the given means the which we need to find, or where we are taking the angle, for that side, that angle opposite side we call it as a perpendicular, and the remaining side will be base. Suppose the angle is given here, then this will become the perpendicular and this will become the base. Means it changes, means where we need to find the angle, opposite to that side, that we call it as a perpendicular, and the remaining third side we call it as a base. So this is what about a right angled triangle sides: hypotenuse, base and perpendicular. Next we are having the trigonometrical ratios. Trigonometrical ratios. There is sine, cos, tan, cosecant, secant and cot. Now let us take one right angled triangle. Here I am taking it as a PQR. Okay. So now you have to find, and now I am taking the angle here. So now here, which is the base, which is a perpendicular and which is a hypotenuse. So here we know this is right angle. So PR is a hypotenuse. Okay. And here is the angle at the point P. So opposite side we call it as a perpendicular. Next this will be the base. Okay. So now we need to find the trigonometric ratios. Here we are having a few things which we have to remember to solve these problems. Okay. So now it is at a point P. So sin P I am taking. For sine we are having the formula perpendicular by hypotenuse. So which is a perpendicular here? QR. Hypotenuse is PR. So this will be equals to QR by PR. PR. Next, we are having cos P. See, this will be depending upon the terms, means given to the vertices, names of the vertices. So here the angle is at point P. So I have taken P here. Okay. So sin P means for sin, you remember this P letter, it might be either A, B, C, D to Z or else theta, whatever it might be the angle. Okay. So the main things you have to remember is sin, cos, tan, cosecant, secant and cot. Okay. So sin means perpendicular by hypotenuse. Next, cos means it is base by hypotenuse. Base by hypotenuse. So what is base here? PQ by PR. Next, tan means it is perpendicular by base. Tan means perpendicular by base. What is perpendicular here? PQ. QR. QR by PQ. Okay, so next we are having cosecant. Cosecant means what? Hypotenuse by perpendicular. Next, secant means hypotenuse by base. Okay, so cot means what do we get? Base by perpendicular. See, these things you have to remember. If not, you can't do this. Okay, so sin means perpendicular by hypotenuse. Cos means base by hypotenuse. Tan means perpendicular by base. Next, cosecant means hypotenuse by perpendicular. Secant means hypotenuse by base. Cot means base by perpendicular. If you observe here, see, sin, cosecant. Sin means perpendicular by hypotenuse. Cosecant means hypotenuse by perpendicular, means reciprocal. So from this what we can say means sin will be equals to 1 by cosecant. Okay, next, cos P means base by hypotenuse. Here secant means hypotenuse by base. See, opposite means reciprocal they are. So from this what we can say, cos will be equals to 1 by secant. Means vice versa it is. Secant will be equals to 1 by cos. Cos will be equals to 1 by secant. Okay, sin also same. Sin is equals to 1 by cosecant. Cosecant is equals to 1 by sin. Next, tan you see, tan is equals to perpendicular by base. Cot is equals to base by perpendicular. So these are also reciprocal to each other. So tan is equals to 1 by cot. And here you observe perpendicular, sin is equals to perpendicular by hypotenuse. Cos is equals to base by hypotenuse. And tan is equals to perpendicular by base. Right? See? Perpendicular by base. Perpendicular by base means what I am trying to say is tan is equals to sin by cos. Means now you take perpendicular by hypotenuse whole divided by base by hypotenuse. So here both denominators are same, means hypotenuse it is. So we can cancel this. What is remaining? Perpendicular by base. Right? That is equals to tan. Tan is equals to perpendicular by base. So from this what we can say, tan is equals to sin by cos. In the same way, cot theta will be equals to, see here, cot theta is equals to 1 by tan, means we will get cos by sin. Okay, so all these are reciprocals to each other. So this is about trigonometrical ratios, and these things you have to remember. Unless you remember, we can't do this. So the main thing from all this starting, you have to learn this till you be able to solve it on your own. Okay, so first of all, you first take a right angle triangle. If you go through the textbook, it is given clearly in that. So once you go through all those things what is given here, so we are having trigonometrical ratios, reciprocal relations, and trigonometrical powers of ratios. Okay, next we will learn about powers of ratios. So for this you have to go through the textbook so that easily you can understand and you can do that. Okay, next we are having powers. Now for example, if it is 4 square or if it is like this 4 power 2 like this, what we will write? 4 square we will write. Now sine theta means theta is one of the angle. Okay, now sine theta whole square it is given. So what does it mean? It means that sine square theta. Okay. So if it is given cos theta whole power 4, it means that cos power 4 theta. Means this power will be applicable for the cos and sine values or secant square, what values are given trigonometrical ratios, for that it will be applicable but not on the power of theta. Means we won't write like this. We won't write like this. This is wrong. We will write like this. Okay, so be careful while writing in the terms of powers. Okay, next we are having square relations in trigonometrical ratios. Means we are having some formulas which we need to remember here. That is sine square theta plus cos square theta is equals to 1. If you need the proof of this, you can go through the textbook. You will come to know how it is proved. Okay, but these are the general things which we need to remember. Okay, next sine square theta plus 1 cos square theta is equals to 1. 1 plus tan square theta is equals to cot square theta. Secant square theta. Secant square theta. Okay, next 1 plus cot square theta is equals to cosecant square theta. Okay, these are the square relations in the trigonometrical ratios. From this again we can frame so many things. Means this will be equals to cos square theta is equals to 1 minus sin square theta. Next sin square theta will be equals to 1 minus cos square theta. Next here, see, secant square minus tan square theta will be equals to 1. Again, tan square theta will be equals to secant square theta minus 1. So, like this, so many we can make from this given equations. So, we have to learn these things and we have to remember in order to solve the problems. Okay, so this is about the introduction of the trigonometrical ratios. In the next session, we can continue with our exercise problems. So, in order to solve the exercise problems, first you have to learn all these things what we have discussed now. If you want a brief,